Dear children, experimental skill is a topic which is very important for NEET examination. So we are planning to discuss some topics, to cover some topics on experimental skills, in which the first topic we are discussing is half deflection method to find resistance of galvanometer. Okay, so the topic is to find resistance of galvanometer by half deflection method. And what all things are required for doing this experiment. Obviously you need a galvanometer and you need a resistance box and also another resistance which is connected in parallel across the galvanometer, a cell and a key. Okay, in fact two keys. For the resistance which is connected across the galvanometer also we will use another key. Let us see the circuit diagram. First of all, a resistance box. The resistance in the resistance box can be varied, so the variable resistance is mentioned here, and then we will connect the galvanometer in series with it, and then we will connect it to the cell, then a key like this. अब इसकी across में we'll have to connect another resistance box that stands for the shunt resistance, which means the resistance box whose resistance can be adjusted for half deflection, and so we need to keep another key also in series with that. Okay, so we mentioned this as S and this as R. Now let us take this key as K1, let us take this key as K2. And first of all, we will keep key K2 open and we will close K1. And let us see a deflection in galvanometer. So in fact, in the first diagram, this S is not included. In the first diagram, this S is not included, and we are adjusting so that a deflection is obtained in the galvanometer, say 30 divisions. Okay, 30 divisions deflection is obtained in the galvanometer for a given value of resistance R. 30 division of deflection is obtained in the galvanometer for a given value of R. You can take any value. For an example, I am taking very small value, but in fact the galvanometer is not a high resistance device, galvanometer is a low resistance device only, and it is very sensitive. So in fact R का value ऐसा नहीं रहता है, काफी high value रहना चाहिए. But for the sake of an example, I am giving you that it is 120 ohm. Okay, 120 ohm. Now we are introducing K2 and we are adjusting the value of S so that the deflection of galvanometer becomes half, which means 15 division deflection in galvanometer, and we have to find out the value of S. And let us assume that the galvanometer is giving half deflection for 60 ohm resistance connected to it. Okay, so galvanometer is giving half deflection when 60 ohm is introduced in this resistance box after inserting key K2. So this time from this experiment we can easily conclude that galvanometer resistance is G is equal to RS divided by R minus S. I'm sorry, RS divided by R minus S. So this you have to calculate and fill in this column. The experiment is now repeated with another value of theta. You can go with 20 divisions, you can go with 18 divisions, as you like. 3-4 tabulations are done, and so these values are taken, averaged, and then finally the mean value is taken as resistance of galvanometer in the experiment. This is how this experiment is conducted. अब हम लोग को देखना है how this expression is coming. In fact, when we are doing an experiment in NEET examination, the experiment is not asking इंस्टेड हाउ द डिफ्लेक्शन हाफ होने के लिए क्या करना होगा, व्हाट इज द थियरी बिहाइंड दिस एक्सप्रेशन, इफ आस्किंग लेट अस सी हाउ दिस एक्सप्रेशन इज कमिंग. So first of all, when the resistance R is connected in series with the galvanometer and no S is connected, at that time some current I is passing through this one, some current I is passing through this one, and that current I क्या होना चाहिए, EMF of the cell divided by G plus R होना चाहिए. Now when we are introducing our resistance in parallel with it, when we are introducing our resistance in parallel with the galvanometer, what is happening? When we are introducing a resistance in parallel with the galvanometer, the deflection in the galvanometer is reduced to half of the initial value, which means the current passing through the galvanometer is half of the initial value. At that time, the net resistance of the circuit also changed, in fact. So the net current passing through the device is also changed. So let us take that current passing through the setup as I2, and the galvanometer से पास करने वाला current definitely I by 2 होगा, and this is the shunt resistance connected. अब शंट से पास करने वाला करंट कुछ I1 ले लो, तो फिर I1 क्या होना चाहिए, देखिए ये तो पैरेलल कॉम्बिनेशन, यू कैन अप्लाई KVL in this loop and you can easily find out, right? So you can say that G into I by 2 is equal to S into I1. तो I1 का वैल्यू तो आपको पता चल गया कि GI divided by 2S है, right? I1 का वैल्यू आपको पता चल गया, this is I1. And now you can find out what is I2. I2 is nothing but the net current, sum of these two currents. इसका मतलब हो गया I by 2 plus I1, which is GI divided by 2S. So just on rearranging this expression, I2 is obtained as I by 2 into 1 plus G by S. Correct na? I by 2 into 1 plus G by S. This is I2. And let us take this expression as equation number 1 and this as equation number 2. Let us write down what is the current right now. I2 is equal to E divided by what is the total resistance of this combination. You can easily suggest, right? R plus GS divided to the parallel combination of G and S. So R plus GS divided by G plus S. This is I2. So this I2 can be replaced here. This can be replaced here. So I am writing E divided by R plus GS divided by G plus S is equal to, I का वैल्यू भी मैं रिप्लेस करने वाला हूं क्योंकि I is equal to E divided by R plus G था from the expression 1. Okay, from the expression 1. So I am writing as E divided by R plus G divided by 2 को ना मैं इस तरफ लेके आ रहा हूं, ठीक है, into S plus G divided by S कर लेते हैं, right? So here E and E cancel हो गया. अब नेक्स्ट स्टेप में हम लोग क्या कर सकते हैं, नेक्स्ट स्टेप में हम लोग इसका रेसिप्रोकल लिख लेते हैं. Let us write down the reciprocal of this expression. So if you are writing down the reciprocal of this expression, R plus GS divided by G plus S the whole divided by 2 is obtained as R plus G into S divided by G plus S. The whole divided by 2 था इधर, so let me write that 2 here. Okay, let me write that 2 here. So after that, on rearranging, RG plus RS, मैंने ना G plus S को मल्टीप्लाई किया, plus GS divided by G plus S is equal to this thing. So इसमें क्या हो गया, ये G plus S और ये G plus S cancel हो गया, and again we are rearranging it. RG plus RS plus GS is obtained as RS 2RS plus 2GS, right? And this 2RS में से एक RS cancel हो गया, टू जीएस में से एक जीएस कैंसिल हो गया, आर जी यहां पर है, सो आई एम टेकिंग जी आउटसाइड इनटू आर एंड दिस जी आल्सो टेकन हियर, जी माइनस जी आर माइनस एस इज इक्वल टू यहां पर क्या मिला, आर एस मिला. सो व्हाट इज द रेजिस्टेंस ऑफ गैल्वेनोमीटर? Yes, you got it as G is equal to RS divided by R minus S. So this is the expression for resistance of galvanometer. Okay.